Okay, good morning everyone. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay. So just wait 1 minute, then I will start. Okay, so let's start. So we have discussed in last classes, this is basically time response analysis of the second order systems. Okay, so in this second order system in time response analysis, we have to cover that is unit step input functions, and we have to follow in this case there are 4 conditions. Okay, that means we have to examples, that is a underdamped response analysis, that means when zeta is less than 1. Okay, and then we have to discover that is the when zeta is equal to that is 0, this is called the undamped conditions. And also we have to know that is zeta is equal to 1, this is also called the critical damp. Okay, so these are the basically basic conditions we have to discuss in last classes, and we have to also follow what is the basic output expression of these different conditions. Okay, now today we'll discuss is another also regarding the second order control systems. There are another topics are present. Okay, my whiteboard is visible, everyone?
Yes, sir.
Okay, so what is critical damping? This is another topics, critical damping. Okay, so this critical damping, we have to learn in last classes, that is a damping, that is zeta, it is equals to the, that is damping. Okay, we have to learn this is the basically damping. And what is the damping ratio? Damping ratio. So this is the basically ratio between the actual damping to the critical damping. Actual damping to the critical damping. And we have to express this is basically zeta omega n by omega n. So that means the factor is coming, that is only zeta. So this zeta, it is called the damping factor, that means damping. Okay, so what is the damping ratio? Damping ratio, it is basically ratio between the actual damping to the critical damping. So this actual damping, we can express, this is zeta omega n divided by omega n, the function is coming only zeta. Okay, So we have learned this is last equations in the second order control systems. So this is basically uses, just wait. Oh. We know that the equation that is output, that is Ct1 minus e to the power zeta omega nt divided by 1 minus zeta square into sine. These are the basically angle omega n root over of 1 minus zeta square into t plus tan inverse 1 minus zeta square by zeta. So this equation we have to learn in our second order response, that is second order control system in the time response analysis. Okay, so this is basically relations of the damping ratio, where we have to learn in 4 cases. This is zeta when zeta is 0 and zeta is less than 1, and another one is a zeta is greater than 1. So please consider these 4 equations. Today it's a little bit whiteboard is disturbed, so just wait.
मेरा WhatsApp कहाँ गया? इसको पढ़ाइएगा ना?
पढ़ाना नहीं, अपने पढ़ेंगे, वो क्या है?
क्या पढ़ रहे हैं?
Please mute
हम भी
yourself.
पढ़ेंगे अपना,
क्या पढ़िएगा?
हमारे मोबाइल से पढ़ेंगे ना तुम।
तो पढ़िए, इतना अच्छा माहौल है यहाँ पर, आराम से पढ़िए। तो शुरू में आप आराम से बैठ के पढ़िए, ये तो यहीं पे
क्या
बदमाशी
तुमको
करेंगे।
ये सब आता है?
Hello.
जहांगीर का पुत्र का नाम जहांगीर जो था, किसका पुत्र था?
ये क्या वो कुछ
ये सब हम लोग में आता है परीक्षा में।
Please
एक
mute
हम लोग
मिनट।
को तो नहीं
yourself.
आएगा।
तुम लोगों का साइंस, तुम लोग का इलेक्ट्रिकल इंजीनियरिंग, तुम्हारा सब्जेक्ट अलग है, मेरा अलग है, तुम्हारा नहीं आएगा।
वही तो
लेकिन जब तुम
मैंने
कंपटीशन दोगे तब आएगा।
Komal,
कोई कंपटीशन में
please
बैठोगी
any
ना,
questions or
तब
otherwise you
आएगा।
mute self. Just wait. Okay, so my whiteboard is visible, everyone?
Yes, sir.
Okay. Okay. So we have to learn the 4 conditions. This is basically over dam, under dam, and critical dam system. Wait for 1 minute, okay? Because my whiteboard is sometimes it is detected or not detected. Next, we have to know that is the what is the characteristic equation of the second order control systems. Okay. Characteristic equations of the second order control system. So we know that that is the transfer function. It is the ratio between the output of the system to the input of the system. That means TF, that is transfer function, it is equals to CS by RS. And what is the second order transfer function? That is omega n square divided by a square plus 2 zeta omega ns plus omega n square. Okay, when this system it is also third order system, the system that is SQ it is also coming. So but in your syllabus only first order and second order systems it is also coming. So here you can see this denominator part, that means square plus 2g zeta omega n is omega n square. It is expressed at is equal to the 0. That means when it is 0, a square plus 2 zeta omega ns plus omega n square, when it is equal to 0, this above equation it is also a quadratic equation of the two roots because it is a second order systems. So now we have to written that is the S1, another one is to S2. This is equal to minus zeta omega n plus minus j omega n root over of 1 minus zeta square. Okay, so this basically S1 and S2, this is called the two roots of this second order control systems. Okay. This is clear all of you? So here this S1 and S2, this is basically roots of the system. So basically the equations, that is S1 and S2. It is basically roots are poles of the transfer functions. Okay, so these roots S1 and S2, it gives the predictions of about nature of the time response analysis. So this is basically time response analysis of the second order control systems. So in that case, we have to learn in transient response. When you have to consider the transient response of the second order control systems, we have to learn these are the basically another terms it is available. Just wait. Next, transient response specifications. Transient response specifications. So last class, we draw one output expressions of this basically four conditions, that is the overdamp, underdamp, and critically damped systems. Okay, so in this diagram, we have to know, just wait, I am drawing these equations. So sorry for today because my whiteboard it is sometime it is detected or not detected. So here little bit problem is arise. Next one, this. So these are the basically midpoint of this waveform. Now we have to learn the output waveform. This is increases, then also decreases. Something this pattern. Okay. CT, and here also we have to consider infinite time ranges. Okay. Oh, So this is the basically starting point, and here one terms, this is TR, this is TR, another one, this is the peak value, that is we have to represent also this is TP. Okay, and here you can see these are the basically upper range of the value, and another one, this is another one. Okay, so here you can see these are the basically plus minus, that means 2% near about to the steady state result, and we know that after the steady state point, this is basically called steady state response. Another one, this is basically called the transient response, we know that. So in this region here we can see these are the basically result near about to the 100%, and at this point this is the 98%, we take that. So this TRTP, and this is basically called the maximum overshoot. Okay, this maximum overshoot we have to consider here, that is MP. My slide is visible? Sorry. Okay, this is basically oh, sorry for the diagram, it is also erasing from here, so little bit this one. So this point, it is called the MP. MP means maximum overshoot. Okay, this is MP, this is TR, another one is the TP. So in this region, that is T is equal to 1 by zeta omega ns. Okay, and another terms, when the steady state we have to consider, that is TS. So these terms, it is very important for these operations. Today's whiteboard is totally disturbed in my class, so I don't know any problem is any internal or any software problem in this whiteboard software. So that's why sometimes it is very disturbing. So in this graph, we have to know that is TR. This is called the rise time. Another one we have to know, that is MP. This is called maximum overshoot. Another one, TP. This is called the peak time. Peak time. So these three terms, it is very important for this transient response specifications of the second order control system. Okay, so just we have recall them. These are the basically output response of the second order control system in the two region. One is the transient response, another one is the steady state response. So in this position, 0 to starting point, that is 0 to this point, this is basically called the transient response analysis. Another one, after this condition, this is result is a stable position, this is called the steady state response also. So in this region we have to note down that is TR, this is called the rise time. Another peak value of the positive region, this is also MP, that is the maximum overshoot. Another one is the TP, that is the peak time. Okay, so these three terms, it is very important. So we have to conclude one by one. First, that is the rise time, that is the TR. Okay, everyone write your own name and roll number in the chat box. And Gautam, you take a screenshot.
Yes, sir.
Okay. So now we have to first include that is rise time. Which is denoted here TR. This is called the rise time. So when the time response it is ranges, time response is 10% to the 90% or 0 to 100%. So this is dependent on the output of the systems. Either it is considered 10 to 90% or 0 to 100% of the desired value of the output of the very first instant. So in this case, when 0 to 100%, we have to calculate the result near about. This is basically called the underdamped response. And when this 0 to 90% response we have to calibrate, this is called the overdamped systems or response. So the equation is coming. We know that previously we have to draw this is Ct equal to 1 minus e to the power zeta omega n t divided by root over of 1 minus zeta square, that is sine omega n root over of 1 minus zeta square into t plus 5. So these are the basically general equations of the second order control systems. Okay, so here you can see when the zeta value it is also ranges 10 to 15%, it is basically 10 to 90% is the system, it is called the overdamped system. And when this is basically 0 to 100%, this is the underdamped response we have to know. So when this is the unit time response we have to calculate, that means we have to experiment that is the result is coming 0 to 100%. In that case we have to put the value of Ct equals to 1. So when this Ct equals to 1, the equation is coming, that is we have to put the value here, that is 1, this is equals to 1 minus e to the power omega nt divided by 1 minus zeta square, this is minus, into sine omega n plus 1 minus zeta square that is omega n root over of 1 minus zeta square into TR. This TR, that means it is called that is rise time. Okay. Just wait. Okay, anyone please confirm me my whiteboard is visible?
No, sir.
Okay. Now it is visible.
Yes, sir.
Yes.
Okay. Okay, so very sorry for that. Today is whiteboard, it is totally disturbed. So that's why the class it is discontinue again and again. And I am reattempt this class also another also timing. Okay, so that's why we have cleared the idea. This is sine omega n plus 1 minus zeta square tr plus phi. Okay, I stop the class right now, okay, because whiteboard is totally disturbing me. So these topics we have to continue in our next classes also. Up to this part I think it is clear also. So we have discussed in last classes, that is sorry, previous slide also, these are the transient response of the specifications of the second order control systems. In this case we have two examples, that is a transient response analysis. In this transient response analysis we have to cover these three terms, that is the rise time we have to express here, that is TR. Another one is the TP, that means the peak time. Another one is the maximum overshoot value. So these three topics, it is very important for your transient response analysis in the second order control systems. So the equation is coming, we have to know that is TR plus CT. When CT is equal to 1, that is 1 equals to 1 minus e to the power minus j omega nt divided by 1 minus j omega, 1 minus j omega squared. Okay, this is basically transient response of the second order control systems. Okay, so I conclude these sessions and these topics. It is also again we have to discuss in next classes also very clearly. Everyone write your name and roll number in the chat box. Okay, so thanks everyone. We will continue in next classes. This topics is also time response analysis of the second order control system in the different conditions, and then the another also time response of the third order control system and higher order control system. But in your syllabus, third order is not available. But we have to certain idea. We give the certain idea of the higher order control systems. But basically, then we have to continue our steady state error analysis. Okay. Okay. So thanks everyone. We will meet next classes also.
Thank you, sir.
Okay. Thank you. Thanks everyone.
Thank you, sir.
Thank you, sir.